Hello students, welcome back. Previously in section 1 we went through the ideas of antiderivatives and took care of all those terminologies and notations. And here's a basic summary. We're going to use these rules, and of course there's some trivial rules as well. Yeah. Okay, alright. Okay, here are some elementary problems. Okay, let's begin. How do we handle this problem? Antiderivative of the first function x cubed. Well, it's going to be this one. Add 1 and divide. And please check. Take the derivative of right hand side. Do you get actually x cubed? I'll leave that to you. Now 3 is coefficient. Keep it there. And antiderivative of x squared using this. Add 1 and divide. And 3 over 3 is 1. So you can write like this. And finally, antiderivative of exponential function, it stays the same. And as usual, we have plus c. That's the completion of the problem. How do you like this? Just using this rule twice and then this rule. Too simple? How about the next problem? Okay, alright. Let's simplify this thing. One way to do that is to use the complete square formula. A squared minus 2ab plus b squared. Square root of y squared is just y, and this one, let me rewrite as 1/2 power. And this one is 1/2 power as well. Do you feel comfortable with this power form? Do you feel comfortable with this complete square? I hope you do. In case you aren't, well, here's a suggestion. Like this, and then FOIL it out and simplify. Do you get this? Please check. Okay, now that we got here, let's find out antiderivatives of these three separately. Antiderivative of 4 is for y. 4 was there before, and then I have to use the power rule. Add 1 and then divide. Alright, did I do this right? Add 1 and divide. Basically this rule. And then this can be written as 8/3. So let's simplify like this. And then add 1 and then divide. Again, I'm using this rule, the power rule. Let's see if I did it right. Yep, correct. So you can break off and then apply the power rule one at a time. How about this? Well, let's see, u to the 4th power, this one here, first power, and then this can be rewritten as u to the 1/2 power, and therefore it can be simplified as u to the what power? It's going to be 3/2 power, 1 plus 1/2. And that's the simplification of this integral. And we'll have to do the antiderivative computation in the next step. Remember, when you use this antiderivative rules, antidifferentiation rules, integral symbol disappears. Integral dx no longer exists. So do not use these rules, any of these rules, to sum of the terms one way or the other. and then end up using twice, apply all at once. A good way is to keep all those integral symbols so that you keep as reminder that I did not take the antiderivative yet. I'm going to take antiderivative of this integrand. Okay, all right, let's go ahead. What's the antiderivative of 5u to the 4th power? Is it good? 5 was there before, but as a matter of fact, add 1 and divide. So we have 5/5. Nobody writes like this. This is just 1. 2 was there before, and add 1, 5/2, and then divide. Ooh, we need reciprocal, so 2/5. So overall, I'm going to get 4/5. Good. And then exponential stay the same. There goes the answer, right? Wrong. What did I do wrong? I used power rule and exponential. Nope. This is not exponential function. This is just constant e to the 4 power. So what do? Constant becomes 0? No, that's not right either. Derivative of constant is 0. Antiderivative of constant is that constant times u, the variable. And then from here you can take the derivative and see. You just get coefficient. Another way to see is to get this u to the 0 power is hidden, and then add 1, so you get 1 power, and divide by 1, so we get that, but nobody writes like this, dividing by 1. And actually nobody writes like this either. So that's how you can do your integral computation, or antidifferentiation. To integrate is to find the indefinite integral. To antidifferentiate is to find antiderivative, but antiderivative and indefinite integral is the same thing. So integrate and antidifferentiate, they mean the same thing. As for the final result, I use the term antiderivative more often, but as for the verb, the process, I use integrate more often than indefinite integral. You can do whatever you would like to. It's just a matter of preference of wording. Here's another example problem here. Okay, let's go. Okay, how do I do this? Again, I'd like to begin with power form first. That way I can cut down a lot of mistakes. If you focus too much upon 1 over something and then focus too much on a log, you may miss something. Anyway, here we go, and let's fold it out. So what do you have inside? First, outside, inside, and last, t times 1 over t. So that's just minus 1, isn't it? So 2 minus 1, I'm going to get 3 like that. So this whole thing is 3t plus log of t minus t squared plus c. Did I do this right? Antiderivative of 3 is 3t. Antiderivative of t to the negative first power. Well, if you add 1, I get 0 power. I cannot divide by 0, so that's not going to be power rule. It's going to be a log function. And then 2t t squared. Did I do this right? I can check. Yeah, that's right. By the way, what is the wrong solution? Oh, simply taking the antiderivative of these and then multiplying them. A rather stupid solution. I haven't seen many students doing that. Okay, enough time for a little bit heavy-duty exercises like these. No, let's stop here and then let's do these problems in the separate video. For now, let's stop.